So let's move on then and consider quite tricky problem. And this is 1574 from the printout set. Okay, let's read this together and consider a wheel that is moving on a wetted road in such a case that velocity of the car is known to us. Velocity of the car is given to 40 feet a second. So if this is our center of the car, then it's only one velocity of the wheel, which is b equal to velocity of the car, and this is the center of the wheel. Okay, so this will be velocity at the point O. Now we also know that at the point of contact, which is point A, the velocity will be not zero, but pointing on the left, and then this velocity of A is equal to 5 feet divided by second. So this will be velocity of car. This is velocity of A, and this will be velocity of the center of the wheel. Okay. So what we need to determine here is the velocity at the point B. So this is the topmost point, and VB is unknown to us. And in the second part is what is the velocity at the point E here, which is on the rightmost point of the wheel. VE is equal to 0. Okay. So let's think, how do we solve this problem? Well, first of all, if velocity of A will be equal to 0, this will be the location of the instantaneous center. Then the problem will be like easy, because all those points will be rotating with respect to point A. Now the problem here is a little bit more tricky, and velocity of A is non-zero, and therefore we suspect the instantaneous center will be located somewhere along this line that connects B and A. Okay. So how do we determine geometrically the location of the instantaneous center? We would connect those velocity from A to B. Okay, so let's connect those velocities here, and this will be the location of the instantaneous center. C is instantaneous center of rotation. So without plugging in all the numbers, let's try to clarify geometrically what's going on with the velocity of any point along this line of the wheel at this particular instant. Okay. Well, we don't have to restrict ourselves to the points A and O, but we can then move on and extend this line to the velocity of the point B, and therefore draw this kind of shear profile and indicate the velocity of any point here by this arrow. Okay. So therefore, this is a complete geometrical solution. We can just take any of the points here on this line, and the velocity, this point will be a rotation with respect to the instantaneous center, and it will be pointing in the horizontal direction until it will intersect this line with this certain slope. Okay. Well, the question then is how to determine like what is the location of the instantaneous center. If we found this magical point, then we can just choose any other point, let's say point B or then point E, and find easily what is the velocity at those points. Okay. So let's do the following. Let's use our previous analysis and connect the velocity of the 2 points that we already know the magnitude of the velocity. So for example, velocity of A is equal to velocity of the center at O plus omega multiplied by RA with respect to O. Okay, so we just decompose again like overall translational motion on the general motion on the translation. So this will be velocity of A, which is when summed with overall angular rotation with respect to point O will give us this relation. So then all the vectors here will be pointing along the horizontal direction. Let's put like all the numbers here so we know that velocity of A is pointing in the negative direction. So this is -5. Velocity of the center is equal to 40. And then omega multiplied by this vector will give us also a negative number minus omega multiplied by the length from A to O. Okay. So then from here we can figure out what is the angular velocity. This is equal to 40 plus 5 divided by the distance from A to O, and this is our radius, is equal to 1 foot. So this is 45 divided by 1 this is 45 like radians per second, and this is the angular velocity of the wheel. Okay. So we figure out what is the angular velocity, but we still don't know what is the location of the instantaneous center. Perhaps the easiest way to do this is to imagine that this point A rotates with respect to instantaneous center with this angular velocity that we already found. Okay. So let's consider this point VA then will be equal to our angular velocity multiplied by the distance from A to the instantaneous center of rotation. So therefore AAC will be equal to 5, this is velocity divided by 45 is equal to 1/9 foot. So this is therefore this distance is 1/9. Okay. So we figure out with this simple manipulation what is the location of the instantaneous center, and then we can just choose any other point, let's say B or point E, and figure out what would be the velocities of those points. So let's start with the point B and determine the velocity of this point. So for that we need to know what is this distance from O to C, and this can be easily computed by realizing that the radius minus our distance to the center of mass is equal to 8 divided by 9 feet. So therefore the distance from the instantaneous center to the point of interest at B will be equal to 1 plus 8 divided by 9 is equal to 17 divided by 9 feet. Okay. Once this is known, then with respect to this point, velocity of B is equal to this distance multiplied by omega. That's all there is. So then therefore velocity of B, which will be pointing in the positive x direction, is equal to LCB multiplied by omega, and this will be equal to 17 divided by 9 multiplied by 45. This is equal to 45 feet divided by second. Okay. Okay. So this we could have done with our previous analysis, but the determination of velocity of E would be rather difficult because we would have to take this vector product between CE and omega, okay, which is relatively difficult. Now with our analysis, now we can just plot this vector from C to E, and our velocity of VE will be just a perpendicular vector to this radius vector. So therefore we can write the answer right away. So velocity of E is equal to LCE multiplied by omega, and this can be found that the distance from C to E can be found relatively easy. So this is point O. I think I need 1 more second here, and if this is 1, this is 8 divided by 9, then the x is equal to square root is 1 plus 8 divided by 9 squared square root, and this is equal to 151 feet. So therefore we can multiply 151 multiplied by 45 radians per second. This will give us 60.2 feet per second. So this is velocity of E, and from this triangle, this theta is equal to tangent theta is equal to 1.9 divided by 8, 1 multiplied by 9 is equal to 48 degrees. So this is equal to theta. So with this analysis, then we can again multiply this vector multiplied by omega and figure out what is the velocity of this the intermediate problem. Okay, in your homeworks, I think we have a couple of problems on this instantaneous center of rotation. I would suggest you start doing this homeworks over the weekend. Okay, so let's stop here.